way you don't have to worry about anything going into the Christmas break. Okay, we're going into the next lesson, which is lesson 6. It's on page 535. Okay, so lesson 6. Okay, so the last lesson we did quadratic inequalities with two variables, and we were shading regions. Note the difference here. Today we're doing quadratic inequalities in one variable, and the solutions, they won't be regions. They won't be a two-dimensional region. It'll be a one-dimensional subset. So something like this, x greater than n. Something like this. Where n is just some number you solved for. Okay, so a quadratic inequality in one variable, it's not a region. Okay, you only shade regions when it's two variables. Okay, that's lessons 3, 4, and 5. Basically 5 doesn't really matter, it's a tech lesson. Lesson 3 and 4. So make a note of that. Lessons 3 and 4 are regions. 3 and 4, you're shading regions. Whereas this one, you're doing intervals. So a one-dimensional, like a line. You're shading a region on the line only. So lesson 3 and 4 is a two-dimensional region, whereas lesson 6 and 7 are one-dimensional. So lesson 6 and lesson 7, you're doing the same process with two different skills. So they teach you two different ways to do the same thing. So essentially, I'm teaching you the last thing today. Tomorrow, I'm just showing you a different way to do it. Thursday is the practice test. Friday is your test. Okay, so let's take a look at this. So they're asking us, okay, where is this graph, or this curve, where is this curve positive? Then they're going to ask us, okay, where is this curve negative? So can you guys decipher that? Where is this curve positive? Where? Where? These guys, right? And you can see this is y positive, right? Y positive is the vertical portion of the graph that's above the x-axis. And then, so where is the negative? Where is the negative? Down here. Okay. But when you go to solve for this, they're going to be asking for x values that make this happen. So the solutions will look more like this. You want to shade the x-axis. You want to shade the x-axis. Okay, so this is what we're looking for. Okay, so let's take a look at this class example 1. It says, complete the following. The solution to the inequality x squared plus 2x minus 8 is greater than 0 is, well, first of all, we need to know where is it 0. So what are these solutions for the x-intercepts? Is it negative 4 and 2? And of course, you could find those places by factoring or quad formula. Okay? So first of all, where is it negative? In here, right? So how do we write that interval for where is it negative? You'd say x has to be less than 2 but greater than negative 4. Okay, so just jot this in. That's where it's negative. That's where the graph is negative, on those x values. And where is this graph positive? I'll use red here. Everything out here and everything out here. So x greater than 2 and x less than negative 4. And then they use the word or, because either will work. Okay. And then they're going to tell you to shade it. So why the open circle? Why the open circle here, here, and here, and here? Because of these symbols, right? Because it's the strictly less, the strictly greater. Okay. And then this is, they do this stuff in junior high, so try to remember, like, if x is less than negative 4, we shade that way, right? If x is greater than 2, we shade that way. If you have the equal to, you close the dot. If it's strictly, you open the dot. Just means you touch it or don't touch. Any questions on that? Okay. Okay, so this one, they're not going to give us anything for free. So you're sitting looking at this equation and you're like, oh my gosh, what do I do? What do I do? Right? So what does this say? What does this mean? What does this even say? It says, where's the curve greater or equals 0? Now, what does the lead coefficient tell you? What does this tell you? What does negative a say? And negative a says we do this. Positive a says we do this. Okay? So you should have a sense of what the graph will look like, and depending on where the graph is, you can pretty much get a sense of this with your graphing calculator, and then you can perform any algebra necessary to show it. Okay? So let's whip this up on our graphing calculator just to get a sense of it before we do the algebra. Okay, somebody read that out to me. Just read it right at starting from 12. 12 plus 4x minus x squared. Okay, so my window's a little bit messed up, so let me just give myself some more x there. Okay, so looks like a -2 and a +6. So like, where's this graph positive? In between. And where is it negative? On the left and right on the outsides. So we already have a sense of the answer here. Now let's try to just prove it with the algebra. Oh, they want us to graph it. Oh, we'll do algebra later. Okay. So, what were those values again? -2? Was it -2? And 6? Okay, I know the y-intercept is the constant somewhere up at 12. And if I go -2 plus 6, what do I get? 4. Cut that in half, I get 2. So at 2, I'll have the vertex somewhere here. So there's the vertex at 2 comma q. I don't know what the q value is, but okay, so if you missed yesterday's class, we've been taking the average of the x-intercepts and then finding that the p-value of the vertex is the average of the x-intercepts. This has to be in between the middle. It has to be symmetric. These x-intercepts are symmetric, so it has to be there. Okay, now if I change this 0 to a y, then I shade a region. Remember that? So remember, that's what we're not doing. Now we're just saying, okay, where is this function bigger than 0? Okay. So what does bigger than 0 mean for the y values? This, right? Is that the part of the y-axis that's greater than 0? Yeah, so where is that going to happen? All this stuff, right? All these y values. All those y values are greater or equal to 0. Do you agree? Okay. So to solve this, we need to use the number line. We say, okay, x will be greater than but less than. How do we write this? Do you guys remember Math 10 doing like domains and stuff? So whenever you have two endpoints, it's really simple to just write those endpoints down, and then remember and just study this, just point the arrows to the left. Why did I use equal to here? Because the question has it. If the question has strictly, then you use strictly. Okay? Okay, so I think B and C need to be reversed, but it's all good. So the solution is this, and then the number line will be down here. So include 6 and go to the right. Include -2 and go to the left. And then if I had, you have to shade it, so. That's what we're looking for. What did I do? Did I do the, oh my gosh. I need more coffee. That's so wrong. Why did I do that? I don't know why I did that. In between. My apologies. My apologies. Okay, we good on all that? Questions before we proceed? So this is solving it graphically, using our graphing calculator to get a sketch. You don't even need the graphing calculator if you got some quadratic skills. Okay, we're going to kind of skip the stuff at the investigation on the bottom here and jump right in. Okay, so let's just pretend this is a brand new question. Okay, x squared minus x minus 20 less or equals 0. We're going to do this with algebra. So we're going to ask ourselves, where is this curve less or equals 0? Before we even jump in there, like what's the a value? Positive or negative? Positive. So it might look something like this. And we say, okay, I want this and I want this, where the graph is positive. So it's probably going to look something like that. Can we factor this guy? What's the factors? Okay, 4 and 5, what are the signs? Okay, so the solutions to the x-intercepts are -4 and 5. So this guy here is -4, and this guy here is 5. So I already know the answer before I do this. I already know the answer. Did I shade the wrong region again? I'll blow this up and make it nicer. Okay. Y-intercept. What's the y-intercept? -20. What's one of the roots? And the other? Okay. Vertex will be closer to which side? The right or the left? Right. So maybe the vertex is down here somewhere. I'm not exactly sure where. Okay, so there's our quadratic. And we're looking for less than 0. So I'm looking for this region in there. You guys agree? Less than 0. So where does that graph dip below the x-axis? Less than 0. Okay, so how to show this algebraically? Okay, so we got to blow this spot up right here. When you multiply two things, that's what's going on here. This is just a product, and this is the benefit of factoring. Because when you multiply something, how do you become negative? What do these two things have to be? What if they're both positive, these two terms? This would end up positive. What if they're both negative? Then they're both. So what do these have to be? One has to be negative and the other has to be positive. So like what's, I don't think I should use the word case, but let's go x plus 4 less or equals 0. And if that's the case, if x plus 4 is less than 0, then what must you say about x minus 5? Does that make sense? When you multiply two things, this is a product. This times this, how do you become negative? One of them has to be negative and the other has to be positive, or vice versa. So here's one of them negative, the other positive. Is there another situation where this could work? Just flip them. Instead of x plus 4 being negative, x plus 4 is positive. And if that was the case, then x minus 5 would have to be negative. Now solve these two situations and you'll see a discrepancy. So x plus 4 less or equals 0, that means x would have to be less or equal to negative 4. And x would have to be greater or equal 5. Is that possible? Can x be less than negative 4 and be greater than 5 at the same time? At the same time. This is impossible. So no solution off that. X cannot be less than negative 4 and simultaneously be greater than or equal to 5. That's just physically impossible. Let's look at this situation. X greater equal negative 4 and that's important, x lesser equal 5. Is this possible? Less than 5 but bigger than negative 4? Yep. And that's exactly what we already knew we were supposed to be getting. Less than 5 and greater equal to negative 4. In 20-1 you have to show these steps, yeah. If this was -2, then absolutely you could just use your calculator. Multiple choice and numeric, do whatever you want though, right? I typically prefer the next lesson better than this. I don't prefer this. Do you have to do them both? Let me double check on that. Okay, let's jump into the next one. It's the last class example. Use case analysis. So highlight case analysis. I personally just can't handle when that negative is there on the lead, so I'm going to take it out. So all the negatives become positives and the positives become negative. And now this one I won't look ahead to the solution, even though I totally could. I could totally just type this in my calculator and just look at it. But that's kind of not the point. Okay, so can I factor this? The AC value is -15, the B value is 14, so it's got to be 15 and 1. What's the signs? -1, okay. So we got a plus 15x, a minus x, a minus 5. Take out a 3x, you get x plus 5. Take out a -1, you get x plus 5. The two factors will be a 3x minus 1 and a x plus 5. So just a review of factoring, nothing spectacular there. Factoring gives us our x-intercepts. X being a third, x being -5. And I'll slow down at this point. Okay, so I feel like this negative on the outside is going to really mess me up because I got to look at like, okay, if this is positive and this is positive, then I'm going to multiply by a negative. So I'm going to multiply that negative in. So I have 1 minus 3x, x plus 5 greater or equals 0. So I'm going to analyze this. That way it's I'm just looking at two terms. So all I did was multiply the negative into the first term. And the only reason I took that negative out is because I'm not used to factoring with this negative there. So that was just a personal thing that I do. And then I don't like this negative out there, so I'll put it back in. So we're looking at this now. So all we've done is factored. And now basically all we're doing is some integer rules. So it's like something times something is going to be positive. So how do you get a positive through multiplication? So 1 minus 3x greater equals 0. And simultaneously, x plus 5 would have to be greater equals 0. Do you agree with that? Or 1 minus 3x would be less or equals 0, and simultaneously x plus 5 would be less or equals 0. Now you solve these and you look for contradiction. So the first one would be 1 greater equal 3x, 1/3 greater equal x, x greater equal negative 5. Is that possible? Can you be greater than negative 5 and less than 1/3 simultaneously? Yep. Now over on this side, 1 would be less than 3x, 1/3 would be less than x, and simultaneously x would be less than negative 5. So can you be at the same time less than negative 5 but greater than 1/3? No. So we have to use this. So solution, number line, greater than negative 5. Close dot because of the greater equal. And then less than or equal 1/3. And then we want in between. This is the solution. Or even this. If you had these two things, and you said over here, no way, then you're good. The blue highlight or that number line with the work shown, that's what you're looking for here. Now, all this algebra is just a real fancy way of doing what most people can do, no problem. Throw this into y equals and find the x-intercepts and analyze it. Where's the graph bigger than 0? Okay. And because this thing opens down, what are the intercepts? Negative 5 and 1/3. Because this thing opens down, it looks like this. So like where is it positive? Well, on this region. You can see the curve goes above. So it's really a simple idea, but the algebra can really toss you around. Okay? So homework will be number 1 for sure. One and 2 are very similar, so you can do one of those. 3. And then 5 is the meat and potatoes of this. This is the one you want to do. For sure, number 5. At least some of them. And then basically the lesson's over, so. Okay, so 1 o'clock, you got 25 minutes to work. Please use your time wisely. Don't waste time.